Some problems with the 3 sets. In a survey, 100 people were asked which forms of transport they used. 46 people used the bicycles only, 21 used the buses only, 11 used motorcycles only, 5 used buses and bicycles but not motorcycles. 9 people did not use bicycles, buses or motorcycles. 6 people used bicycles and motorcycles. 3 used buses and motorcycles. How many people used all 3 forms of transport? Let us set up a Venn diagram. Shall need a Venn diagram for this. I told you the reason for using different colors. Let us assume, let C denote bicycles, C for bicycles, B for buses, and T for motorcycles. They said 46 people used bicycles only. That means that you are lying outside the circle for buses and outside the circle for motorcycles. It is just bicycles only. As you can see, those 46, they are only lying on in the black circle. They are lying outside the set for buses and the set for motorcycles, but they lie in the one for bicycles only. 21 used buses only. Even the 21 is there. We are putting there 21 because they said buses only. The word only is there. If 21 used the buses, the working would be different, as you are going to see in the examples that will follow this one. 11 used the motorcycles only. So again we have 11 there for motorcycles only. Then we have that 5 used the buses and motorcycles, but not motorcycles. Oh, it is buses and bicycles but not motorcycles. So those 5 are lying there. Look at a case where you have the intersection of buses and bicycles, but outside the motorcycle set. Those are the 5. Then 9 people did not use bicycles, buses or motorcycles. So those 9 people are supposed to be outside there. They lie here outside. Then 6 people used the bicycles. 6 people used the bicycles and motorcycles. So now here you are saying that this one was used the bicycles and motorcycles. If I would write this one as in set notation, it is a C intersection C intersection T. This one is bicycles and motorcycles. That one is T. They said these were 6. Then we have the number of this is buses intersection motorcycles still, that is 3. Now this one is different from the 5 here. For this particular 5, they say the 5 used buses and bicycles, but not, you see this phrase here, but not motorcycles. That was the phrase that is making this thing be there the way it is. Buses and bicycles, but not motorcycles. That's why that one is there. But now for this one, for this 6, they said 6 people used bicycles and motorcycles, and they didn't say anything. So those are the people who used both bicycles and motorcycles, regardless of whether they used the buses also. Among those 6, there are people who also used the buses, but the moment they use bicycles and motorcycles, they are being counted among those 6 people. So if we let we can select the number of elements in C intersection B intersection T be equal to X, that this one is now X. And they say that the intersection of bicycles and motorcycles is 6. So this one should be 6 minus X, while this one is 3 minus X, because the intersection of bicycles and motorcycles is 6. So I should have this one, if this one is X, I should have this one as 6 minus X, such that when I add everything there, I should get the 6. The same applies to this intersection for the buses and the motorcycles. 3 use the buses and motorcycles. They didn't say, but not bicycles. So we don't just put it there. Then they say how many people used all 3 forms of transport. It is done. We have just assumed it to be X. And now what we are going to do, they gave us this universal. This one is 100. Now what we are going to do, let us add everything inside the quadrilateral and we equate it to 100. So we shall have 46 plus 5 plus 21. We are adding everything inside the circles and even that 9. So you have 21 plus 6 minus X, then plus X plus 3 minus X plus 11 plus 9, adding everything inside there to get us 100. And now when I add 46 plus 5, that is 51, plus that 72, 78. This one is 78 plus 3, that one is 81. Plus the other one, 21 plus 20. That one is 101. So when I add all the numbers, I get 101 minus X. This X will cancel with that X, and remaining with only this minus X which I put there. It is equal to 100. Now negative X is equal to 100 minus 101. Negative X is equal to negative 1. Negative X over negative 1, such that X is equal to 1. Therefore, the number of elements in C intersection B intersection T is equal to 1. How many people used all 3 forms of transport? That is that one. This one is number 2. A travel company in the USA finds 100 tourists who have been on a safari holiday. 30 have visited only Kenya, 14 have visited. Let us see, still get a Venn diagram for this. The number of elements in the universal is equal to 100. They said 30. Let us see. Let K be the set of tourists who have visited Kenya. Let T be the set of tourists who have visited Tanzania. And G be the set of tourists who have visited Uganda. So we have K, this is T for those who visited Tanzania, and this is G for those who visited Uganda. I'm trying to make this one different so that you can. So they said that 30 visited Kenya only, so that one is 30. We have some 14 who visited Tanzania only. Then we have some 8 who have visited Uganda only. 6 have visited Kenya and Tanzania, but not. Check this. It is there. So the 6 people we are having, they are lying in Kenya and Tanzania, but not Uganda. Then 5 have visited Kenya and Uganda, but not Tanzania. 5 have visited Kenya and Uganda. So those 5, they are in the intersection of Kenya and Uganda, yes, but outside Tanzania. That's what they mean here. You have the intersection of Kenya and Uganda outside Tanzania. It is that point there. Then these 2 have visited Tanzania and Uganda, but not Kenya. So those ones are to be put at that point there. Those 2 are there. Then they said 14 have visited Kenya, Uganda, and Tanzania. Equally, the 14 are supposed to be there. And they said draw a Venn diagram to illustrate this information. We have done that. How many of the tourists have visited Uganda? Actually, maybe, but saying how many of the tourists have not visited any of the 3. Maybe we can assume we have an X there. So to answer part B, where they are talking about how many have visited Uganda, you look for everything inside the set for Uganda. So those who visited Uganda there is saying how many visited Uganda only, and then saying how many visited Uganda. So those who visited Uganda only, they were already given, there were 8. They visited only Uganda. However, those who visited Uganda, there are those who visited Uganda, but they also visited other countries. So visiting Uganda means that you are, even when you go to other countries, you have still visited Uganda. So the people who visited Uganda, the tourists, we have 5 plus 14 plus 2 plus 8, and this is getting us 29 tourists. So I have 29 tourists visited Uganda. 29 tourists visited Uganda. That is what we have there. And then we have part C is asking for how many of the tourists have not visited any of the 3 countries. So could there be some people who are not lying within these 3 sets? Let us add everything inside the quadrilateral and we equate it to 100. If there is a value for x, then it will mean that those are the people who didn't visit any of the 3 countries. So we have 30 plus 6 plus 14 plus another 14 plus 2 plus 5 plus 8 plus x, the x outside, should get us 100. Now when I add everything there, if at all I add all the values I have there, I have 30 plus 36, that one is 50, 64, I have 79. This one is 70, 79. So 79 plus x, I should get 100. So that x is equal to 100 minus 79, giving us an x which is equal to 21. So the value of x is 21. And so part C, that's how many tourists have not visited any of the 3 countries. That one is 21. 21 tourists, they didn't visit any of the 3 countries. Okay. Question 3. A school had 25 candidates for UCE. 5 students passed only physics, 3 students passed only mathematics, 1 student passed only English, 4 students passed English, mathematics and physics, and 6 students passed mathematics and physics. 9 students passed mathematics and English, and 7 students passed physics and English. How many students failed all 3 subjects? For this particular number, let me try to give some analysis, because there are cases where you may need to make some analysis before you draw the Venn diagram. So the analysis we can make, I'm just trying to put it so that you can learn how to make the analysis of the information given. The universal contains 25. Now 5 students passed only physics. This is the number of students who passed physics, and the subjects we have are physics, mathematics and English. So we shall assume that E is a set of students who passed English. And similarly, we have M for those who passed mathematics, and P for those who passed physics. So when you see M, you see P. That one is physics, M is mathematics, and E is English. You are supposed to write these things properly. I'm just illustrating there so you know what you are doing. So this one is P intersection M complement intersection P complement. That is what this one is not P, but it is E complement. That one is 3 students passed only mathematics, or 5 students passed only physics. This is 5. That's what it means to pass only physics. Failing math, failing English. Then the number of the 3 students passed only mathematics. So this is M intersection P complement intersection E complement. That one is equal to 3. We have that one student who passed only English. Number of English intersection P complement intersection M complement. This one is 1. 4 students passed English, mathematics, and physics. This one is English intersection math intersection physics. They say this way. These were 4 students. And then 6 students passed math. They said, and 6 students passed mathematics and physics. This is math intersection physics. These were 6. 9 students passed mathematics and English. Mathematics intersection English. These were 9. And 7 students passed physics and English. Physics intersection English. These were 7. How many failed? All 3. Failing all 3 means that you are lying outside the complement of the union. So this one is M union E union P complement. Let it be equal to X. It is the one we are looking for. So what we are going to do, we shall use a Venn diagram. Let us draw a Venn diagram here. That is P M E. Now for these 3, this one was lying for, like this one is lying in P alone. That is P only, physics only, math only 3, then English only, that is 1. When it comes to the 4, that one is also there. When it comes to now this one was here, the X, that X is now out there. However, when it comes to this 6 here, 6 is the value which is supposed to be here. M intersection P. 6 is the value which is filling this space. This is the intersection of mathematics and physics. It's supposed to be 6. Now that part of it is 4, the part which is remaining, because the intersection, this one, M intersection P, has 2 parts. This one and then this one. So since this one is 4, this one should be 6 minus 4, which is 2. And then this 9, M intersection E, is also here. The whole bit of it, the whole chunk from here around there. So this one should be 9 minus 4, which is equal to 5. Then the 7 is this and that, which will render this one 3, such that when I add the intersection of, you can see the intersection of the blue, the intersection of the black and the red circle is the intersection of math, of English and physics, one which is 7. And the universal set was given as 25. Can maybe put it here, that this is 20, 25, that when you add everything inside there, you should get 20, 25. Now, what we are going to do to find the value of x, we are going to add everything inside here and we equate to 25. So we have 5 plus 2 plus 3 plus 4 we should get 20. That is the sum of everything inside the two circles. And when we add everything there, we are getting what we have there is we get 23. This is 20. Get your calculator and add everything there. You shall have that. So 23 is plus x is equal to 25, implying that x is equal to 25 minus 23, getting us an x which is equal to 2. So we can ably conclude and say that two students failed all 3 subjects. They lie out. They are cheating outside here. They cheat outside the three sets. They are not lying in any of the 3. So those 2 failed all 3 subjects. This is example 4. You can realize that each question is having different requirements. Each question bears different requirements. However, the one of analyzing, you need to analyze them. But I was just doing without writing the analysis. It is sometimes daunting to students. So we have the Venn diagram shows people in a school, in a school class, who play mweso, chess, and draughts. How many students play only chess? Only chess. I shall write this part A. Only chess. That one is 8. You can write in a full sentence and say that 80. Are there people? Yes. 8 people play only chess. In a full sentence. I'm just writing this because the system I'm using to write, guys, I don't want to write the whole statement, but you can write it. Or I'm dictating, you write 8 people play only chess. Yeah, you have written it. So we have B, part B. Those who play all 3 games. That one is this point there. Those ones are the ones who play all the 3. And there are 3 also. So 3 people play all 3 games. Then this one actually was trying to see how we understand the region is none of the games. That one is 2. These 2 here. Those who are cheating outside there. So two people play none of the games. Then D, we have those who play mweso. So I have 15 plus 1 plus 3 plus 2. we are talking about all of these people inside that thing for mweso, inside the mweso thing. We are adding all of those ones in the red. Everywhere in the red circle is the one signifying the set for mweso. So you have this one as it is 20, 21. So 21 people play mweso. 21 people play mweso. Part E is asking for those who play chess and droughts. Chess and droughts. It is this intersection there. That one is for chess and droughts. So we have 3 plus 3, which is equal to 6 people. Which is equal to 6 people play. Do you go on? 6 people play chess and droughts. That is what we can say about that question there. So this one has been in words. We now have this one which they have given us in symbols. Yeah, we need to know the symbols and the words, because when we are describing sets, it was somewhere in senior 1 where they taught that the methods of describing a set, you can just list the elements, you can give it in words, whatever. So around here, like here, they have told us, they talk about mweso, they talk about chess. Now here they are using symbols. We can solve it. So T, this one is number of elements in T intersection P intersection C. That one means those who are existing in all the 3 sets. Like they have presented this Venn diagram, you have red, blue, and green. So look for the elements that are existing in all of the circles, you see. So number of elements in T intersection P intersection C is equal to 5. It is this one here. That one is lying in all the 3 sets. Number of elements in T. Number of elements in T. This one is 9 plus 4 plus 5 plus 7. Add everything inside the that one is inside the red circle, and this one I guess it should give us something like 25. So the number of elements in T, you just add up everything inside here, and that's it. Then part C, number of elements in T intersection C. T intersection C. It is this one here. That is the intersection T intersection C. And what is in that intersection? From what you see there, we have 7 plus 5. That is T intersection 7 plus 5, which will get us 12. Then part D is asking for part D, number of elements in T, also in C, but not in P, because we have a complement here, means outside. So we are looking for elements inside the T, but also inside the C, but outside the P. Inside the T, inside this, but outside that, it is that 7. So part D, the number of elements in T intersection C intersection P complement is equal to 7. And the way I'm writing this, it is not n. You take a note. Don't write an n for the intersection sim. I'm trying to resist it. You can also resist it. Don't use an n. Then part E, this one is now existing in P and C outside T. Let me just write it there. That one is equal to in P in C, in P in C. It is that one outside T, T complement outside T, but in both P and C. It is only that one there. Then here, number of elements in O, T union P union C complement. They have given us something on the complement of the union. Okay, we can get it. What we are going to do, since they gave us the universal set as 50, we shall try to add everything inside there and see whether we can get shall add and see whether we can get something which is greater than 50. So what we are going to do, let us put there some x. So let this value be equal to x. And when we get that, actually this is how we can denote those members who are always existing outside the 3 given sets. Now what we shall do, we have 9 plus 4 plus 5 plus 7, then we add on plus 3 plus 1 plus 13 plus x equal to 50. We are adding everything inside this quadrilateral and we are equating it to 50. This x is part of the quadrilateral, so we are also adding it here, as you can see. So around here we have this one is 25, 28, 29. Yeah, we have this one as it's giving us 42. 42 plus x is equal to 50. When I add all of these numbers, I'm getting 42, such that x is equal to 50 minus 42, and x is equal to 8. So we have that 80. Oh, it is not any writing. So we have that number of T union P union C complement is equal to 8. Let's see what we have there. If you okay, we are proceeding. The government of Uganda, is it the government of Uganda? Yes, does a survey of post offices to see which of them offer. So what we are going to do, shall we assume, it is already assumed that T is the set of post offices offering telephone services. Then X is the set of all post offices that are offering taxi services. F is the set of post offices offering fax services. Let us try to put this in some bit of the number of elements in the universal is 100. Number of elements, there is 100, and then 83 offer telephone. Telephone is T. That one is 83. Then we have the other one we have there is 47 of terex. So for x we have 47, then 19 of this one is now f. Number of elements in f is equal to 19. They said 13 of all 3. F intersection x intersection t is equal to 17. They offer all 3, and 13 offer none of these. So this is f union x union t, the whole chunk complement. This one is equal to 13. This one is the complement of the union. So the union contains all those inside the 3. So the three sets, and this one is now the complement of the union. So it is 13 lying outside. 27 of we have number of elements in 27 are telephone, which is a t intersection f. T intersection f, that one is O. There is something more. They said this, but not T. So we are here, but not fax services. So these 27 are offering telephone, and actually it is let me clear this. It is supposed to be telephone. The 27 is telephone and telex intersection f complement. This is 27. That is the 27 we have there. And the other one is 1. Is that 1? Offering. There is one offering telex, which is x, and intersection f, but not telephone, but not t, which is that is 1. They said draw a Venn diagram and represent this information. We can represent and draw that Venn diagram. Let's call this T, call this F, call this X. There are those that are supposed to be just put, like we have the 13 out here, the one who's existing in the complement of the union. Then we have some, the one, which other one is supposed to be put, we have this 17, shall put it there also. Then we have in the intersection of there is the intersection of t intersection x intersection f complement. There is this is 27. Shall put it there. Why? Because that is the intersection of telephone and telex, but not telex. 27 offer telephone and telex, but not fax services. So outside F, inside T and X, but outside F. There you are. Then we have put this. We put this. Now we are putting this X intersection F. This is 1. It is a 1. And then what more? That is all the information which we have. We have these others. We have the universal set, which contains 100, and we can call this, let's call this A, let's call this B, and we call that C. Then we call this X, because the question is here is saying that how many post offices offer fax and telex services. How many offer telephone and fax? This one was telephone and fax, but not telex. That is the X which we have there. So that one you can assume it is X. Then part B, fax. How many post offices offer fax and telex? Those ones are 18. Fax and telex. We just need to add this plus that already there, and we get that answer. But we shall have to let's find for the values of A, the value of B, and the value of C, which can also help us get the value of X. First of all, let us get C. We can get C by getting 27 plus 17 plus 1 plus C. When you add everything there, you should get the one for X, which is 47. Add everything here. This is the set for X, and equate to this one here, the number of elements in the set representing the post offices who are offering telex services. So when I add everything here, this one is I have here 44 plus 1, that one is 45. So I have 45 plus C is equal to 47. C is equal to 47 minus 45, giving us C as 2. That is one thing we have got. We also need to get we have to add all of these ones here, add these and equate to 83. So we have that A plus X plus 17 plus 27 is equal to 83. So that A plus X plus we have I'm putting 24 there, sorry, this one is 27. I'm adding everything here. A plus X plus 17 plus 27, everything inside the T, and I'm equating it to 83. Why? Because number of elements in T is 83. So when I get 17 plus 27, that one is 40. I get 44, everything equal to 83. Such that now A, I shall write A in terms of X is equal to 83, 44 crosses the equal signs, goes there, becomes minus, and then X also crosses and becomes minus. So A is equal to, this one should give us 39 minus X. That is the value of A. We shall also add everything here, and we equate it to the set for F, which is 19. X plus B plus 17 plus 1 is equal to 19, such that read properly. X is equal to, we are not looking for X, we want to write it, we want to write B in terms of X. This one is equal to 19, this one is 18, so 19 minus 18, then minus X. So B is equal to 1 minus X. That is some other thing which we have there. So after having that, why are we doing this? The information which they gave us information that can help us fill here, fill there, but we had these parts here, all of them. How could we put something here when this one is X, this one was not given, and even this were not given? But they gave us the values for each of the complete circles. So they are the ones we are using to get the values of AB, and see in terms of X, so that we have only X in the equation. So what we are going to do, we are going to add everything inside there, and we equate it to 100. Add everything inside the quadrilateral and equate to 100. So we have A, which is 39 minus X. I am adding this A, which is here. So A, let me go to B, plus B. So I'm adding on B, which is 1 minus X. After that, I add on C, which is 2, plus, let me add the X, 27 and 1. I'm adding everything. So I have X plus 27 plus 1, add even the 17, the one in the middle, and then add this 13 here. Add that 13 also, because it is also part of the post offices that were examined in the survey. So we have this one equated to 100. When you work out all the numbers here, 39 plus 1, that is 40, plus this plus that plus that, press the calculator, we are going to get 100. And now the x's which we have here, there is this x and this minus 2x plus x, that is minus x. So 100 minus x is equal to 100, implying that x is equal to 0, because what do you subtract from 100 to get 100? It should be a 0. So x is 0. Now the question is saying how many post offices offer fax, that is F, and telex, this one here. We could get that without even writing this, but this is for part 3. So for part B, the answer is supposed to be 17 plus 1, which is equal to 18. Those are the post offices that are offering F and X. Then part C, is asking for how many of a terex and fax, but not terex. T, F, but not this. So inside T, inside F, outside X, it is that X. So we have that 0 because we got X equal to 0. So 0 post offices. There are none of the post offices offer telephone and fax services, but not terex services. That one was basically a 0. I hope you have got that. Yeah, let's finish with this. It is a long video, you have to bear with me. You can always pause it and relax and then come back. I'm not mean that you should sit once and study all of this stuff. You'll have your brain is vibrating. You may not get what you are reading, so I've got to read and watch and relax, then come back and watch, and then practice and practice and practice. I think that is the golden rule of mathematics. If you do that, be assured of the distinction. Practice, practice, practice. Rule 1, practice. Rule 2, practice. Rule 3, practice still. So they have done a lot of analysis here. I'll just make a Venn diagram. Oh, snaps. Shall just make a Venn diagram. That color. Okay. Which color should I put this? I didn't hear. They gave us the letters already, so we have E for elephants, L for lions, and R for rhinos. They said we have 20 East African national parks, so we have the universal set there is 20, and the number they find that E intersection L intersection R complement. In E, in L, outside R, it is this region here. That's why we have the 2 there. Then we have N. This one is L in L, but outside E, outside R. That one mean this one means L only. That is 1 L only. Because we are seeing a complement there and a complement there. Outside this, outside that, inside L only. Then this one is only in R. So R only is also 0. R only. That's how we write it symbolically. Outside, a complement of L, complement of E. Just R. Then this one is E union L union R complement. That one is outside. That's why we have the 3. Number of elements in E. This one is just E only. That one is 8. E only. Because you can see number of elements in E, intersection L complement, intersection R complement. And remember, intersection means existing in all. So 8 exists in all of these. It exists in E, and then the complement means outside L. So it also exists outside L. and also exist outside R, and that is it. This position here is outside L, is also outside R, and it is inside E. That's what we have there for that particular aid. 5 parks have elephants and rhinoceros. So now this one here, if I'm to write this one in a symbol, it is E intersection R. They said that is 5. And then for that 4, these parks have lions intersection rhinos. That one is that is 4. And now they said draw a Venn diagram to show this information. How many parks had all 3 of these animals? So there are things we don't know, but they said in the intersection of E and R we have 5. So this region here, this region there, when I to fill it, everything there should be 5. While this region here, L and R, this region to fill it, everything there should get us 4. L intersection R. Now what we are going to say, we shall let that this intersection of all of them, let it be X, so that when this part is taken up by X and this sort of thing should give us L and R should E and R should give us 5. This one should be 5 minus X, while this one, which is 4, will get us 4 minus X. And basically that one is the Venn diagram which we have there. Now what we are going to do to get the values of the unknowns, we shall add everything inside the quadrilateral and equate it to the universal. So I have 8 plus 2 plus X plus 5 minus X plus 1 plus 4 minus X, okay, plus 0 plus 3, add everything there, and you shall get 20. We have added this, that, this plus that, plus this, plus this, plus this, plus that, plus that, plus that 3. It's also added. Don't forget that 3 outside there. When I add everything here, this one is 10, 20, I'm getting 23. And the x's which I'm having here, this one is cancelling that and I have minus x. So I have 23 minus x is equal to 20, such that 23 minus 20 is equal to x, and 3 is equal to x. Turn the equation around, x is equal to 3. How many parks had all 3 of these animals? 3 parks had all 3 of these, all 3 of the animals. That is the analysis there. That's the solution. So we have had all those examples. What you need to do, practice, get more numbers from whatever sources and try to apply the methods you have just learned in this studio, in this video, and try to take your teacher for some bit of marking and show that you have done some research. And also practice. I told you practice and practice. And after practicing, you practice and practice. Peace.